Welcome back, Chemistry 30. This is the determining the percent of acetic acid in vinegar lab. So we'll go through all the things you need to know here and what exactly you need to do. So first of all, what you'll be doing here is a titration, and a titration is a procedure for determining the concentration of an acid or base by neutralizing a known volume of the acid or base with a solution of a standard base or acid. So we're figuring out what the concentration of an unknown acid or base is by adding the opposite, base or acid, that we do know the concentration of. And from doing the calculation that we did in the 19.4 booklet, we'll in fact be able to determine that. So standard solution whose molarity has been accurately determined experimentally, so that's kind of part one of this experiment. You'll be making a standard solution, and you'll know the concentration of it hopefully, and then you'll add it to vinegar and we'll be able to figure out the amount of acetic acid in it. So just to review a few things, in a titration, one solution is added slowly to the other until the equivalence point is reached. At the equivalence point of a neutralization reaction, the moles of acid and moles of base are equal. An indicator placed in the reaction mixture tells you by means of a color change when the equivalence point has been reached. Your experimental data, the volume and molarity of the standard solution, and the volume of the unknown acid or base solution are all that you need to calculate the molarity of the unknown acid or base. In this activity, you'll first make a standard NaOH solution. You'll then use your standardized solution to titrate a sample of vinegar. Vinegar is a solution of acetic acid. So the H, C2H3O2, so the hydrogen ion with the acetate ion. From your titration data, you'll be able to calculate the number of moles and the mass of acetic acid in your vinegar sample, and then determine the percent of acetic acid. So we're not figuring out the molarity of the acetic acid. We're actually going to determine the percent of acetic acid, and of course compare that with what's written on the bottle. So problem, what is the percent of acetic acid in vinegar? Some objectives here: make a standard solution of NaOH, determine the molarity of the NaOH solution, and then determine the acetic acid in vinegar, the percent. Materials are included here, and of course safety goggles, etc. Sodium hydroxide is toxic, caustic. Wipe up any spills to avoid slippage, and let me know if something gets spilled. So part one, making the standard NaOH solution. So we want to make a 1 molar NaOH solution, and of course we need to use C equals N over V back from unit 2, determine how many moles of NaOH will be required to make. Now how much of this do we want? 250 mils. And of course we change that to liters, that's 0.250 liters. So we know V, 0.250 liters, we know C, it's 1.0, so rearrange this to solve for N. Once we know N, number of moles, of course, we don't have mole balances, we have gram balances, so we have to convert that into grams. Grams of NaOH, so of course we need to use the periodic table, figure out the molar mass, and then from there convert from moles to grams. And then so once we know how many grams, use a 250 ml volumetric flask and a method used from unit 2 to correctly make 250 ml of a 1 molar solution. No, I don't have I don't have 250 ml volumetric flasks for everyone. So what we will use is a fleeker. So I'll show you what that looks like in class. So grab an empty bottle, mass out the NaOH, put it in there, and then top up to the 250 ml mark so that we have our solution. And make sure you stopper it and shake it until all the sodium hydroxide is dissolved. Quite often people don't dissolve all the NaOH and the results don't work out that well. Remember, we're making a solution here. All of the NaOH must be dissolved. So make sure you don't see any sitting on the bottom of the fleeker. All right? So that's part one. You'll have your bottle of NaOH, which you'll use throughout the experiment. And then you'll make up this setup with the burette. Your sodium hydroxide will go into the burette. Use a funnel, it's a lot easier, but just be aware the burette fills up really quick, fills up faster than you think it does. So when the level gets up to about 3/4, maybe slow down, and just to make sure it doesn't overflow. So of course fill it up just a little bit past 0, and then you can always put your fleeker underneath here and gradually let some out until it sits at the 0 mark. And again, remember, you're going to read from the bottom of the meniscus. Okay? And on the bottom, of course, your vinegar will go in the flask, but what we need to do there first is couple of things. Determine the mass of about 30 mils of vinegar in a tared Erlenmeyer flask. So here's your Erlenmeyer flask. Put it on the balance empty, zero it, and then you'll have a grad cylinder with 30 mils of vinegar approximately. Pour it in the flask and tell me how many grams it is. So mass of vinegar. You have your empty fleeker zeroed. After you pour in 30 mils of vinegar, what is the mass? Okay, and then fill the burette with NaOH solution. Okay, we talk about that. So it's at the 0 mark. Record this as the initial volume. So at the start of this, of course, initial volume of NaOH, this will just simply be 0 because this is the first time we're doing it. Next, add 3 drops of phenolphthalein solution to the flask containing the vinegar. So, and of course, as I mentioned in class, phenolphthalein is clear and colorless in acids, but it turns hot pink in bases. So you won't see a change here because it's in vinegar, which has acetic acid. So 3 drops. Just because you don't see anything doesn't mean it's not there. Don't put 20 drops because you think, oh my gosh, it didn't do anything. It's okay. 3 drops is all you need. Place the flask under the burette, and then you can lower this burette in here a little bit so that the tip is somewhat in the flask, so to avoid splashing. If it splashes on the inside of the flask. Begin the titration by adding small amounts of NaOH to flow into the flask containing the acid. Swirl it around with your hand to make it mix in. You may want to put a piece of white paper underneath. It's easier to see color change. You'll see splashes of pink because we're adding base into there, but that pink will simply disappear. Until you're getting close to the equivalence point, the pink will persist longer and longer until eventually it turns hot pink. Hot pink is too far though. You want to get it so that it's a light colored pink. So once you see that color staying for a while, you may want to slow down and just add drop by drop. And ideally, what you're looking for here is once you've added something, it's clear, but 1 drop turns it light pink. That's the point in which you want to stop. A stream turning it pink is overshooting it. You've gone too far. Basically, you want 1 drop to cause the change to happen. Continue to add drops, okay, until the light pink is colored. Record the final volume of NaOH. So how much did it take to get that to turn it to light pink? And then you subtract, and then volume of NaOH used, and there we go. Now, the burette holds 50 mils of base or whatever we put in there. If you find that you used up less than 25 mils of sodium hydroxide, you don't have to refill it for trial 2. Just continue from where you left off, because when you do it again, it should be less than 25 as well. So you can continue going downwards. So the initial volume of trial 2 may be where you left off over here with trial 1. Or if you found that you used more than 25, then yes, you'll have to fill it up to the top. But otherwise, just continue from where you left off. Then, of course, trial 3, you'll have to fill it up to the top again. So we're going to do this 4 times. If you find that you made a mistake and you overshot, you got to redo it. So maybe insert that trial over here or erase your material that you had here. Okay? So as I mentioned here, if you overshoot the equivalence point, discard and redo the trial. Do not record it. So we're looking for 4 good trials here. So if you run out of room here, you may have to set up a trial here. Doesn't matter. Don't worry about the bottom 2 parts here and this part, because what we'll do is we'll just simply answer it in the following questions here. Okay? So over here, once you've done each trial, it says here, use the molarity of NaOH solution and the volume of NaOH to determine the moles of NaOH used to titrate the acetic acid. So we have our concentration here. 1.0 molar is what our NaOH is. That's what we were supposed to make. And then what volume did we use here? What volume? So let's say I used 25.5 mils. Okay? That, of course, is going to be decimal 0.255. Now, I'm off by a decimal point here, obviously. So move the decimal 3 places to the left. This should have been, if I'm doing a hypothetical example here and use 25.5 mils, this should actually be the decimal 0.255 liters. And then you get your moles. So you do that for all the 4 trials. The equation for the neutralization of acetic acid. So acetic acid combined with NaOH. So you can see here we get water formed, HOH, and then sodium acetate. And of course, sodium is positive 1, acetate is negative 1. So it's going to be a 1-to-1 ratio.
Sophia Stang, Randa
Then, of
Schmidt,
course,
Vanessa Morin,
since we
Abby
have
Gilmore, and Alex Cannon, and Jaden Lynn.
moles
Thank
of
you.
NaOH, to figure how much moles of acetic acid, we simply use the balanced equation, and guess what? So we take our moles from our previous answer. 1 mole of NaOH reacts with 1 mole of acetic acid, so guess what? It's going to be a 1-to-1 ratio. Nothing's going to change here, but you still need to include this step. If it had been a 2-to-1 ratio, of course, things would change at this point. So we'll know moles of acetic acid. Now, we're not going to figure out big C for acetic acid. We're not figuring out molar concentration, we're figuring out percent. So what we need to do is convert that into grams now. So you'll have to determine the molar mass of acetic acid, and from there take our moles of acetic acid, multiply by the molar mass, and get how many grams of acetic acid were actually in that vinegar sample. Okay? So do that, and then of course to figure out our percent of acetic acid, it involves figuring out our mass of acetic acid, which we just figured out in number 7, divided by the mass of vinegar we originally had, and then multiply by 100. So out of that vinegar we had, what mass of it was acetic acid? So we determine that from that neutralization calculation. And then of course we'll get our answer here. For number 9, take the average of these 4 values, so add them up, divide by 4. And then lastly, of course, if you look at a vinegar bottle, it says 5% acetic acid, so you'll likely get a little bit less than that as your average. So take your average value, your observed value that you got, subtract 5, divided by 5 times 100, and you'll get your percent error. Then 10b, suggests some errors that could have contributed to any deviation from the experiment. So why didn't we get exactly 5? Tell me some things that could have been wrong or in terms of measurement. And remember, one of the big things here is that when we made our original solution, we didn't use a volumetric flask, which is what you're supposed to be using. We used a fleeker, and you'll see when you look at the fleeker that it's not the greatest way of determining a solution concentration, so that could be one error. And then mention a few other things here that could have led itself to being off by a little bit. All right, we'll see you again.